It's great to meet you at DEF CON here. And in this session, I'm going to be introducing a easier to use alternative to Elasticsearch that a friend and I have been working on for the past several years called Typesense. And I'm super excited to be here and to be talking about Typesense. So quick background. So I'm co-founder of Typesense. So before we started working on Typesense in about 2015, started out as a nights and weekends project. And then we started working on it in full-time in 2020 after we started seeing good traction. I'm based out of Houston. Before this, I was at Dollar Shave Club, head of engineering there. And before that, I was at or actually I was at Verisharp, and then before that I was at Dollar Shave Club, and then before that Block Beacon and Dun Bradstreet. So let's jump into what Typesense is. So at a high level, so it is an open source search engine. One of the key things that is about that's special about Typesense is that typo tolerance is built in, which we realize that for most site and app searches, typo tolerance is something that people typically want. So without any configuration, typo tolerance comes built into Typesense. And Typesense stores all its indices in memory. And this is unlike Elasticsearch, where the indices are stored on disk and with a cache on in RAM, whereas in Typesense, given that RAM costs have been declining over the years, we've tried to focus on building something that's memory first with a backup of the actual data on disk. It's very similar to what Redis does, and we built it in C++, super mature ecosystem. So we've been able to stand on the shoulders of giants and focus on the core search pieces while we leverage best-in-class other open source libraries for things like clustering, the HTTP layer, etc. And the key thing that we've optimized Typesense for is speed. So, and given that it's an in-memory data store, this is what enables us to have a fast speed in Typesense. And that enables search as you type experiences, which I'll touch on a little later. The other thing that we've also optimized for is what I call developer happiness. And what that really means is we want to simplify the amount of effort it takes to learn, a new search engine, the amount of effort it takes to deploy Typesense to production. We want to minimize that effort as much as possible so that everything feels intuitive. There are a lot of defaults in place, so you don't have to worry about the parameters tweaking if you don't need any special use cases. So it works out of the box is what we've optimized Typesense for. And we have about 9,000 stars on GitHub so far. We have about 2.4 million Docker pulls, and it's continuing to grow, which I'm super excited about. And we're now hoping that we're able to share what we're working on with Typesense with more developers around the world. So all of this comes down to speed, like I was saying. So we typically aim for sub 50 millisecond searches in Typesense with millions of records. Of course, if you have hundreds of millions of records, you probably might see 100 millisecond or 200 millisecond results, but it's still sub-second, less than 500 millisecond results is what we aim for. And that's what I meant by speed. And by developer productivity, I meant default, so configuration parameters just work without you having to tweak it too much. And all of the names of all of the configuration parameters, we've spent so much time making sure that they're intuitive so that it makes sense just by reading it. So you don't have to go and read through detailed documentation to understand what it exactly does. The other big thing that we've done is we've adopted a RESTful API, and sure, Elasticsearch also has a RESTful API, but they also have a DSL within the API that you have to learn and understand. Like the JSON structure that you send into the APIs is something that you have to learn and figure out. Whereas in Typesense, all of the parameters are flattened out. There's just one level of parameters. So every parameter, you read it, you understand how to use it. There are only a couple of ways to use it, if not one in many cases. And the other big thing that that falls under the developer productivity is low operational overhead. So in Elasticsearch, you have you have to worry about the JVM, you have to fine tune the JVM, and then you have to fine tune Elasticsearch, which I think has almost like 3,000 different configuration parameters. In Typesense, on the other hand, it is a single self-contained binary. So there's one binary that you deploy, and with no runtime dependencies, that scales out of the box to to hundreds of, if not thousands of connections per second. So without you having to fine tune any other parameters needed. So that's something that, and even with clustering, which I'll touch upon later, there's also low operational overhead. So it's super easy to get a production ready multi-node cluster going with Typesense as well. Yep. The other thing, so I touched on runtime dependencies. So like I mentioned, there's no JVM. With clustering. It's the same binary that you deploy to additional clusters. Unlike some other clustering systems where you have to deploy like either Sentinel nodes or external nodes just for monitoring the cluster. In this case, every node has a replica of the data in Typesense and also is able to participate in quorum to figure out if the cluster, which nodes are healthy or not healthy. By just pointing the IP address at each other, they start forming a cluster with each other. The other big feature that we've simplified in Typesense is the ability to launch geo-distributed clusters. And what I mean by that is it's like a CDN where the closest node to the user serves traffic. In a similar way, in Typesense, you can deploy these nodes in a cluster across multiple regions, like geographic regions. And we've optimized Typesense to work over, even the clustering to work over high latency networks as well, so that even if they are geographically distributed, they're still able to serve traffic. So that allows you to do things like serve search results from the node that's closest to the user, just like what a CDN does, and also have your entire data set replicated across geographies. So now many of these things are possible to do in Elasticsearch. The thing is, it's hard to pull something like this in a production setting that scales out of the box. So combine all of that together with simplicity is what we've optimized Typesense for. And like I was saying, it scales out of the box, and I'll show you a couple of examples in the next couple of slides. All of this helps you build what I like to call search as you type experiences. So typically, in the past, maybe where if you see a search bar on a site or an app, you have to you type something and then you press enter and then you start seeing results. That is, I would say, the previous generation before, the pre-Typesense world of doing searches. Now, because all your searches are optimized for typically to return in less than 50 milliseconds, you can actually start showing results for every key press. So users don't have to type something and press enter. Instead, they type one letter and the results start showing up, and then they type another letter, the results start refining in real time. That actually helps improve user experience for users and allows users to explore more results from some research that people have done, some UX researches that people have done. So that's something that we have optimized Typesense for, and that's what Typesense allows you to build. So here's what I mean by search as you type experience. So this particular showcase has 2 million recipes indexed in a Typesense cluster. And if I start searching for, like, for example, pizza, if you notice, as I keep typing every single letter, results are returned in as little as 26 milliseconds. So, if I type pineapple, so if you notice the time here, it still stays below 50 milliseconds for a lot of these keywords. So that is what search as you type means. So instead of typing something and then pressing enter and then waiting for these results to show up, the results start showing up right away and update with every single key press, even for millions of records. So another example is even with a larger data set with 32 million songs, even in this, as you start typing letters, it starts showing the results right away. Even in this case, with 32 million songs, it's showing results in as little as 25 milliseconds. Now, of course, as you start adding filters, it does go up a little bit, but still, it's still under 500 milliseconds. And that allows the user to quickly get the results that they're looking for without having to wait for your typical spinning, loading spinners, etc. So that helps users explore more of your data set quickly. And of course, things like faceting is there. So if you notice here, there are counts that get returned based on the results here. For this result set, the amount of results that have 1990 as the release date is get shown. Authors here can facet on different fields, different in this case, authors, genres, etc. And highlighting, of course, these come out of the box with Typesense. So the results are highlighted with an HTML mark tag, or you can configure it to a different tag. And so everything that you need to render the search results in a UI comes built into Typesense. And that's what I meant by developer productivity. We've optimized it so that it's you can build search UIs pretty quickly with Typesense. Now, does it scale? So here are a couple of benchmarks that I want to share. So the 2.2 million recipe data set that I was just showing you, it has recipe names and ingredients as well. That indexed on a 16 GB RAM 4 vCPU server. Now, of course, this actually has more capacity than this data set actually needs. I believe this data set only needs 1 GB of RAM to index in Typesense. It took 3.6 minutes to index the 2.2 million records. So indexing speed is super fast. And in fact, we've improved it as well in the latest release candidate builds. And it was able to scale up to 104 searches per second in terms of concurrency with just 4 vCPUs. So that's how far Typesense can scale with still an average search time of just 11 milliseconds per search. And here's another example. So with 28 million books, titles and authors and the category of the books, again, indexed on the same server with 16 GB of RAM. I think this particular data set actually took, I believe, 14 GB of RAM just because of the size of the data set and the number of unique book titles there are in the world. That took 78 minutes to index the 28 million records. So indexing time does go up with more records, but still 28 million records, it takes about an hour and a half. And it was able to scale to 46 searches per second. And it did all of this out of the box and with a search time of 28 milliseconds. It did this out of the box without any tweaking. So all I did was launch a new Linux VM and install the Typesense binary and index the data and ran the benchmark suite against it. And it scaled out of the box without having to do any additional tweaking, either at the Typesense layer or even at the OS level. There was no additional tweaking that was needed. Another example that I haven't included in the slides, but another example that I saw with the user recently is they indexed about 4,000 records, get a small data set, but they indexed it on a 512 MB RAM machine with just 2 vCPUs, and they were able to get almost a 2.5 thousand, I guess 2,500 requests per second on a 3-node cluster. So, and I wasn't able to benchmark it higher only because my benchmarking test suite that machine didn't have sufficient capacity, but 2,500 requests per second. So it can scale to that much as well, depending on how much vCPU you have. So if you throw more vCPU at it, Typesense will just take advantage of the more computing power, and it'll be able to scale to more searches per second. Let's talk about Typesense in the context of Elasticsearch. So now Elasticsearch is a great general purpose search engine, and it has a whole bunch of features. You can pretty much do anything related to search with Elasticsearch, but that's the blessing and the curse with Elasticsearch is with that broad level of feature set, it has a complex learning curve which takes weeks for someone who's just starting out with Elasticsearch to get accustomed to. And in addition to site and app search, and what I mean by that is, if you want to implement app search for just your website, or let's say in your mobile app, in Elasticsearch, you are also able to use it for things like log search. You can use it for security incident monitoring. You could do it for, you could use it for anomaly detection, aggregations, analytics. So there's a whole bunch of use cases that Elasticsearch can be used for, and that's what makes it versatile for a whole bunch of use cases. But that also adds the complexity of knowing exactly which of subset of features you need to use for your particular use case. And of course, it's built, like I was telling you, I actually grepped through the Elasticsearch code base, and I found over 3,000 different configuration parameters that allow you to tweak various behaviors in Elasticsearch. And on top of that, there's also, because Elasticsearch runs on top of the JVM, you have to fine tune JVM. And sometimes you need to understand how Lucene works as well, because Elasticsearch is built on top of the Lucene search library. So sometimes you have to go to that level of detail to really figure out what subset of parameters that you need to configure to get Elasticsearch to do what you want it to do. Whereas in Typesense, like I mentioned, there are no external dependencies. It's built in C++, so we don't rely on Lucene. We've actually built the foundations from by ourselves without relying on an external library, with, again, this core goal being we wanted to simplify things as much as possible, and we wanted to build something that's in memory rather than disk-packed search algorithms. And because of the external dependencies, there's also a lot of production overhead. And in fact, interestingly, Typesense itself was born out of our frustration with Elasticsearch, like running Elasticsearch in production. We'd regularly have to fine tune the indices and rebalance shards and the whole 9 yards, that we would have to continuously spend time to optimize Elasticsearch to get it to continue running the way it ran when we deployed it the first time. And that's when we were so frustrated that we were like, can we simplify this process? And maybe naively, we asked ourselves, can we build a simpler search engine? And that's how Typesense was born. Now, over the years, we realized how much effort it takes to build a search engine. And I'm glad I didn't know that when we started out building Typesense, and I'm glad we stuck with it now. But we've gone through all of that process to build Typesense as simple as possible, so that teams around the world, without having to worry about production overhead and integration complexity, to just deploy it, and it works without you having to worry about infrastructure overhead. The other thing that I mentioned about geo-distributed clusters, in Elasticsearch, it is possible, but setting it up is non-trivial, and getting Elasticsearch to work over high latency connections is quite the challenge. Again, you need to know which configuration parameters to tweak to get it to work. So it's expensive, and it's also time consuming to pull off with Elasticsearch. So the other thing that's surprisingly hard in Elasticsearch is if you want to do multi-field prefix search and you want to have typo tolerance enabled, it took quite some time to figure out that, how to do it. And I think over the years, another thing is Elasticsearch has added multiple features on top of each other. So you need to understand which of the features are the new way to do something, which are the features you have to still rely on some of the old behaviors. And that happens typically in any product that has been around for a while, where you have a lot of features, but then you also have to know which subset of those features you want to use, and versus which features are new versus which features are old. So with Typesense, so we have the hindsight of the learnings of the journey that Elasticsearch went through, that that Solar went through, and also another company called Algolia went through. So we've taken all of these learnings that we've seen other search engines do, and we now have the benefit of hindsight, and we've been able to improve Typesense based on that. So here's one quick example by by the API, like how different APIs can look like in Elasticsearch versus Typesense. So I wanted to do turn on typo tolerance and do a prefix search. So the endpoint in Elasticsearch has just has a /_search endpoint, so it's not really RESTful. But if you switch over that for a second, or look past that for a second, inside the payload that you send into the Elasticsearch endpoint, you need to know the exact format of this particular DSL, where you need to know that, oh, there needs to be a top-level key called query, and within that, there needs to be a key called multi-match. And these are the fields within multi-match. And here, this particular thing didn't actually work with phrase prefix search. So you need to know that this parameter doesn't work when the type parameter is set to phrase prefix. So you need to learn this DSL reading through pages and pages of documentation with Elasticsearch. Whereas in Typesense, we've simplified the same query, like the intent of what this query is trying to do. We simplified that with, if you notice, the first thing is that this is a RESTful, RESTful-ish, I like to say, RESTful-ish endpoint, where a collection, we call an index a collection, and the name of the collection and the documents within that collection, you're trying to search on it. And you just pass the API key and you say, I want to query by this query term, and I want to query these fields. Typo tolerance is built in. We don't have to configure it. You can, of course, turn it off if you want to. And you can also say, this is the field. So title should be weighted higher than ingredient names. That's out of the box, just by you putting title before ingredient names. So this is just one level of parameters that you need to understand. It's all documented in one page. You'll be able to do a search query, an equivalent search query, without having to learn a whole new DSL. So that's what I meant by we've simplified the APIs as well compared to Elasticsearch. Now, if you've heard about this search engine called Algolia, it's a proprietary product. It's a SaaS product. You might have seen them in some of the documentation sites, for example, for React, and I think even the Vue. In many backend libraries also use in the Algolia for their to power their documentation search. They're a proprietary search engine, and in fact, they have. They're very close to Spirit and Typesense in that they're also an in-memory data store. And they've actually solved a lot of these pain points that I'm telling you with Elasticsearch. They've also done a similar thing with their product as well. But like I said, they're proprietary and it's a hosted SaaS search engine. There's no open source. You can't self-host it if you want to. We've also solved some important limitations and quirks that Algolia also has in their product, because their product is also, I think, maybe 8 years old at this point. And if you want to create additional sort orders, like for example, in an e-commerce site, if you want to do sort by price ascending and sort by price descending, in Algolia, you have to duplicate your entire index, so as many sort orders as you have, which increases your memory consumption and your price. In Typesense, it's just single index to sort on multiple fields. And if you want to run Typesense in, Algolia in a CI environment, for example, if you want to run integration tests, that's impossible to do in Algolia. Of course, you can do it, but the cost will be super prohibitive to do. In Typesense, because it's self-hostable, we publish Docker containers. We also publish a Linux binary. You can run it even as part of your CI pipeline, and you can run it locally as well, and deploy the same binary to production and without doing any additional work. Now, for folks who don't want to worry about self-hosting at all, based on feedback from users, we've also launched Typesense Cloud, which is a managed version of Typesense, where you click a couple of buttons, you're given an API endpoint and an API key to send the data to and start searching. And even here with the billing model is something that's completely different to what Algolia does. They charge for a number of records and searches, which makes it very expensive to run at scale. In Typesense, we charge like a cloud. We charge like an infrastructure provider, like based on number of based on the amount of RAM you use and the amount of concurrency you need, which is the amount of vCPU cores that you need. So typically that ends up saving almost 95% of costs compared to Algolia. And we've also integrated with a search UI library that Algolia has open sourced, just the UI library. So you can use the same UI library with Typesense. Now, I think Elasticsearch also very recently published a new UI library that works only with Elastic right now. And we have to start looking into how to make that work with Typesense. But in general, the approach that we've taken is that there's an adapter that you can add into any UI library that can then translate the queries to something that Typesense understands instead of just whatever that library was built for. So that's the approach that we've taken. So it's a matter of building additional adapters. So all of that said, I've talked a lot about how easy it is to get up and running with Typesense. So I want to show what that looks like. I want to start with a bare bones repository and show you a live demo of how easy it is to get up and running with a search interface, like end to end, all the way from pushing the data into Typesense to having a search UI, and then I'll show you how to add more elements to the search UI as well. All right, so we published this starter template here, where all you do is clone this oops. So all I'm going to do is do a clone of this repository. Oops, it's from my previous run. And let's go into this directory. And I'm going to open it with my editor here. Yeah. And just to show you what the bare bones app looks like, let's actually start quickly install the dependencies here. So it essentially has a couple of dependencies here and the Typesense library, and it has an HTML file, which with bare bones, like a container to say, to hold the search panel, the search results, and a pagination widget. So once this finishes, I can show you how the bare bones app looks like. No, let's start the Typesense Docker container first. So I have this little Docker command, which starts it on a particular port with this particular data directory, with this Typesense version and an API key, and I'm going to enable course here. So I have that in a npm command here. Oops, npm run. So this is Typesense actually running in a Docker container. So it says node becomes leader. So it's now a single node instance. And then I'm going to do npm start. Before that, let's index the data into Typesense. So for that, I have this little script. I can walk you through that. So all it does is it establishes a connection to Typesense here, and it defines a schema. So we're going to be using a books data set, which I'll show you just now. You define what the data types are, or we also have a auto schema detection in Typesense. So you can just have, for example, a regex field names, and you can say auto, and Typesense will auto detect these field names for you. And then we're deleting the collection if it already exists, and then creating it and importing this data set. And we're calling the bulk import endpoint to push the data into Typesense, and then checking for errors. So here's how the data set looks like. So it's a bunch of JSON documents with title, authors, publication year, some rating, etc. So I'm going to first run this script to populate the Typesense index. So let's open a new tab here. Done. So it added about 10,000 records here. It created the schema, and then it added 10,000 records. Now, if I go to localhost 3000, so this is that demo app. So this data actually comes from Typesense. If I start searching for something here, like Hobbit, for example, so it starts returning results right away. Now, like you're up and running. So it took me probably less than maybe 10 minutes to get this going. Now, let's say you want to add a filter to filter by maybe author name here. So I'll show you how to do that quickly. So we've already published the author name into Typesense. So now it's a matter of updating the UI here. So let's say, I think I call this, there's some CSS attached to this. So filters, and then let's add a new container to hold the author's filter. And I'm going to go to this where I've configured the widgets. So if you notice, this configures the search box, this configures the results page, this configures the pagination widget. And I'm going to add a new widget here saying it's called a refinement list. And if I say container, I want to mount it on the DOM element with called authors. And in the document, I wanted to use the authors field from my data set. And that's pretty much it. So I have auto reloading turned on here. That's why I automatically did it. And that's it. So now I have a widget that automatically shows me facets by the authors field and shows me these counts. And it lets me filter here. So if I want to search again, let's say Harry, and I want to search only for these authors, it actually does an OR. You can change it to do an AND as well. So it's that easy to get up and running with Typesense. So if you want, so by default, Typesense actually estimates the amount of facet counts. You might have noticed that. So if I add exhaustive, I think it's called exhaustive search. And if I refresh that, now it shows me, so it estimates it for performance reasons, but in some cases you want to show the exact accurate counts, then you start showing, you turn that on and it shows you the exact counts. So that's pretty much it with how easy it is to get up and running with Typesense. Now, the other things that I want to go back and share is we have a built-in production grade HTTP server in Typesense, and this is the same. It's called H2O, and it's written in C++. It's actually used by Fastly in production on all their edge servers. So it's been battle tested, and it's open source. So we've been able to, like I mentioned, stand on the shoulders of giants. So we've been able to just use that within Typesense and not have to reinvent the wheel. There's also the concept of multi-tenant API keys. And what I mean by this is, let's say you have a certain data set where only some records can be searched by some of your logged in users. In that case, you can generate API keys and have them scoped to only certain records so that if the record only has a user ID of 10, for example, only user ID 10 when they've logged in can access those set of records. If they try to access any other records, it'll deny access to it. You can even use that to limit particular fields that have that you can access. So for example, if you have admin users who can access certain fields, and then maybe a different role of users can't access certain fields, you can use scoped API keys to limit what a subset of data or fields that particular users can access. And we also have this feature called grouping and distinct, where let's say in an e-commerce store, if someone is searching for a shirt, you don't want to show them the same shirt style in, maybe you have 10 different sizes and you have 5 different colors. You don't want to show all of those together. Instead, you want to put all of them together in one unit, and so that users can see more variety of results. Then you could group all those results by the attribute of color and maybe a type, and only show them a subset of results so they get more variety in the results. So all of that said, one of our big goals with Typesense, it's, we want to democratize search. And what I mean by that is we want people to be able to use a search engine without having to worry about how complex it's going to be, or will I have to learn a whole new thing, and how much time is that going to take, or not have to worry about costs of scaling as well. Like once you deploy to production, we want to minimize the amount of time you need to have to spend thinking about your search. You deploy it and it just works out of the box. So that's what I mean when I say we want to democratize search. So and we want as many developers as possible around the world, regardless of team size, to be able to adopt Typesense. And that's one big reason we've open sourced 100% of Typesense. In fact, we run the same open source version of Typesense in Typesense Cloud as well. So any improvements that we make as we see Typesense being used in production in Typesense Cloud, we add that into the open source product. So it makes its way back into the community. So if someone's self-hosting it, if they already have infrastructure engineers and you're self-hosting it, then it just works out of the box. And you benefit from the improvements that we make, because we're dog fooding Typesense and running it on production ourselves. So we'd love to invite you on this journey. We're a super small, lean team trying to do big things. So we'd love to have you contribute. There are key things that we're looking for. So we're looking for client libraries in more languages. We already have, I think, about 8 or different integrations. There's always more libraries where we can't be experts in every single library. We'd love to have more maintainers for these libraries, and also authors for new libraries. And then there's also integrations with frameworks. Like, for example, we have a Python client, but then we'd now like integrations with Django. We have a Ruby client. We have a work in progress Rails integration. We'd love for more framework level integrations like this. So again, we can't be experts at every single one of these frameworks out there. And the final thing is tutorials. There's only we've put out a lot of documentation, but then we'd love to have folks use Typesense and share their experience and help build walkthroughs for other users using particular sets of technologies together, because the number of permutations of different types of technologies that you can build these days is seemingly limitless. So we'd love for more and more tutorials that are written for specific sets of technologies together. And so we'd love to have your help there. And that's pretty much it with Typesense. So if you have any questions at this point, I'm happy to answer. Or you can also reach me on Twitter. We also have a Slack community that if you want to join and have any questions, happy to answer them.